Hey y'all, Data Guy here, and today I have a video for you where I am going to show you how you can run containerized or non-containerized Java applications using Airflow. So while a lot of times, people think of Java as kind of a legacy tool, it's not really used that much anymore, there's still so many organizations out there that have super specialized Java applications that are sitting on a VM somewhere that are actually powering a lot of their business. And a struggle a lot of times because these are basically just bespoke applications that are sitting alone in a VM. They're really hard to integrate with the rest of your integration pipeline. And this kind of holds true for really any remote process that doesn't exist as its own kind of entity. So instead of, hey, I can easily make an API call to Snowflake, or I can use a container registry operator to spin up a container and then, run that container with an application. I'm more focused on, hey, this is an internal VM someone's running and it's really hard to connect to. And so what I want to show you today is some different ways that you can use Airflow to connect to, manage, monitor, trigger with configurations that Java application that lives in an external VM. So without further ado, let's get into it. So the first thing we'll do is just set up a basic Airflow environment. So open a new terminal window here, cd into my chosen repository, and then make directory remote Java trigger, and then cd into remote Java trigger. And here's the little Datadog here to say hi. Say hi, Datadog. Datadog. He actually had the idea for this video today. He's really passionate about external Java machines. So here now, once we have our empty folder, just going to run astro-dev init in there, create an empty Airflow repository, and then go and open that up. So 1 second while I pull this up here, remote Java trigger. And then what we'll do is start customizing this image so we have everything we need. And honestly, this is a pretty simple process because all we're going to need to add here is just make sure you have the SSH operator installed. So Airflow providers, SSH, save this here. And then we can go and start building our DAG. Also, if you happen to need to install like anything that wouldn't be a pip install package or a pip install, you can add it to this packages.txt file. And this will allow you, sometimes you'll need to have a specific driver or something installed on the machine that's calling that Java application. You'll either want to include that in this packages.txt file or from within this Docker file here if it's something that needs to be triggered on startup. But let's do now is go and create a new DAG, Java application trigger .py, and now we can get started building our basic DAG. So the first DAG I'm going to show you is going to be pretty basic, just showing you how you can just SSH and then trigger a remote Java application. So here, just bring in the SSH provider, and then we're just going to define a simple DAG, external Java trigger, wrong one, that's the exact same. So here, external Java trigger, nothing really fancy here within the DAG definition. But what we'll show you now is the task to actually trigger that Java application. So at the most basic level, what you're just going to need to do is have an SSH operator that's going to use an SSH connection. So this is where you're actually going to define your connection details to SSH into your actual chosen machine. And then within that chosen machine, you're going to use this command line field to actually choose the command to run your Java application. So here, instantiate Java, use.jar, and then trigger this application, this .jar file here. And so this will obviously just be the path to your application. And then you'll also want to make sure you have this do xcom push to actually capture the output of that command. What this will do is say, hey, let's say you trigger this command and you get an error message or you get a message saying, hey, you're not allowed to do that. This is where you want to capture that output, push it as an XCOM, and make sure that you can check downstream, hey, did this actually trigger successfully? Since the SSH operator won't monitor that on its own. So then what you're going to want to do next is actually define a second operator, which is going to manually check those Java application logs. So here you have, again, using the same SSH connection, just going into the log path for your application, and then again, capturing the output there and pushing it into your XComps. And what this will do is, both give you, hey, was this triggered successfully or not? And then also, what were the logs, what was the information around the output of that task? And this is where you could swap out that .log for really whatever information you expect to be generated by your Java application there. So really easy to set up. And this is really all you need for the basics. But what I want to now start showing you is different ways that you can layer on top and bring in different types of credentials and things like key files to connect to more difficult to connect to Java VMs. And so the first thing that is useful to have is the ability to actually tell your Java application to use a config file. So sometimes you'll have a Java application that needs to it's basically just kind of a black box. It'll do let's say a data transfer, but without a config file, it's not going to know where to transfer the data from, where to transfer the data to, and so that's where being able to layer in at runtime, hey, this is the specific config file you want to use, likely having multiple different config files for multiple different use cases that you can select here. And this is where you'll add that to the command to make sure that that Java application is actually triggered with that config file. So really, just an easy way, but just something that's useful for actually making sure that you're using the right config and giving you some flexibility in how that's triggered. Another thing that you might want to do is before actually trying to trigger the application and this is also just good for testing and making sure you can trigger it, is use the SSH operator to go in and echo, hey, Java version, and the environment is ready. And this will give you the actual Java version, and also if Java isn't installed, it'll throw an error there, but it's also just a simple command you can run and immediately get feedback on whether or not Java is installed in the environment and actually make sure that you're able to run the Java application there. Now, some other things you can do to kind of layer in or incorporate additional configuration is maybe you actually want to update the config file before triggering the Java application. And so here, what you can do is actually so get some configuration details from your DAG run. So if you want to pass it into an API call to a DAG run, and then actually save those in a config file within your remote VM, and then use that config file to tell that Java application how to behave. So if you don't want to have, to define those config files separately and then have to, manage them separately, this is a great way to have that happen dynamically and also give you, single source of truth for all the different configs used by each runtime rather than needing to go into the code and see, all right, what config file was used here. So really useful. And then another thing you can use is checking for a running application. So this will capture the output of a log, the log output, but sometimes you actually just want to monitor. And so here, what you're going to do is just run this command here using the SSH operator. And what this will do is check if your application is actually running or behaving as expected after it's launched. So this is really good if you're trying to catch some errors or monitor applications that might always trigger successfully, but there's a high chance that something goes wrong after that application was triggered. So really useful tool here. And then another thing you can do, and this is only actually if you have a health checkpoint or an endpoint exposed via REST API on your Java application, is you can use something like the HTTP sensor to trigger query the health of your Java app. This isn't going to be for everyone, but it is an option to basically have a continual monitoring process for your Java application that doesn't rely on SSH, but instead relies on an HTTP sensor. Another thing you can do, and just like best practices, is having a cleanup file. So make sure you clean up any temporary files within the temp directory here that were used by the Java application or used during just any part of the process, making sure it all stays clean. And then finally, one other thing you can do is actually trigger a DAG with parallelism. So if you want to run your Java application, multiple threads of your Java application at once, you can actually expand this, pass a list of config details. And this, again, you can use the same methodology of passing it in at DAG trigger or having these be stored within the same VM as the Java application. And then use this to trigger that application several times with several different configurations. So obviously we'll need your application to be able to be multi-threaded, but still useful if it is. So that is everything I really wanted to go over today. I think it's everything that's relevant for just quick primer on how you can manage and monitor remote processes that you're running in Java applications. And above all else, I hope you learned something. I hope you have a great rest of your day. Data Guy out.